Additional topics in probability and counting. Objectives. How to find the number of ways a group of objects can be arranged in order. How to find the number of ways to choose several objects from a group without regard to order. How to use the counting principles to find probabilities. Permutations. An order arrangement of objects. The number of different permutations of n distinct objects is n factorial. N factorial is equal to n times n minus 1 times n minus 2 times n minus 3 so on, 3 times 2 times 1. 0 factorial is equal to 1. Examples: 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1 is equal to 720. 4 factorial is equal to 4 times 3 times 2 times 1 is equal to 24. Example for this is the objective of a 9 times 9 Sudoku number puzzle is to fill the grid so that each row, each column, and each 3 times 3 grid contain the digits 1 to 9. How many different ways can the first row of a blank 9 times 9 Sudoku grid be filled? The number of permutations is 9 factorial is equal to 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 362,880 ways. Permutations of n objects taken are at a time. The number of different permutations of n distinct objects taken are at a time. NPR is equal to n factorial over n minus r factorial, where r is less than or equal to n. So the example for this is find the number of ways of forming 4-digit codes in which no digit is repeated. You need to select 4 digits from a group of 10. N is equal to 10, r is equal to 4. So 10PR is equal to 10 factorial over 10 minus 4 factorial is equal to 10 factorial over 6 factorial is equal to 10 times 9 times 8 times 7 times 6 factorial over 6 factorial. We have to cancel the 6 factorial and 6 factorial. So equals to 5,040 ways. Another example is each year 33 race cars start the Indianapolis 500. How many ways can the cars finish first, second, and third? You need to select 3 cars from a group of 33. N is equal to 33, R is equal to 3. 13 PR is equal to 33 factorial over 33 minus 3 factorial is equal to 33 factorial over 30 factorial is equal to 33 times 32 times 31 times 30 factorial over 30 factorial is equal to 32,736. Distinguishable permutations. The number of distinguishable permutations of n objects where n sub 1 are of one type, n sub 2 are of another type, and so on. So n factorial over n sub 1 factorial times n sub 2 factorial times n sub 3 factorial times n so on, where n times n sub 1 plus n sub 2 plus n sub 3 plus so on is equal to n. So example for this is a building constructor is planning to develop a subdivision. The subdivision is to consist of 6 one-story houses, 4 two-story houses, and 2 split-level houses. In how many distinguishable ways can the houses be arranged? There are 12 houses in the subdivision. N is equal to 12, n sub 1 is equal to 6, n sub 2 is equal to 4, n sub 3 is equal to 2. 12 factorials over 6 factorials times 4 factorials times 2 factorials is equal to 13,360 distinguishable ways. Next is combinations. Combination of n objects taken are at a time. A selection of r objects from a group of n objects without regard to order. NCR is equal to n factorial over n minus r factorial times r factorial, where R is less than or equal to N. So the example for this is a state's Department of Transportation plans to develop a new section of interstate highway and receives 16 bids for the project. The state plans to hire 4 of the bidding companies. How many different combinations of 4 companies can be selected from the 16 bidding companies? You need to select 4 companies from a group of 16. N is equal to 16, R is equal to 4. Order is not important. The solution, 16C4 is equal to 16 factorial over 16 factorial. 16 minus 4 times 4 factorial is equal to 16 factorial over 12 factorial times 4 factorial is equal to 16 times 15 times 14 times 13 times 12 factorial over 12 factorial times 4 times 3 times 2 times 1 is equal to 1,820 different combinations. Another example for the finding probabilities is a student advisory board consists of 17 members. 3 members serve as the board's chair, secretary, and webmaster. Each member is equally likely to serve any of the positions. What is the probability of randomly selecting the 3 members who will be chosen for the board? So order is important. There is only one favorable outcome. There are 17 P3 is equal to 17 factorial over 17 minus 3 factorial is equal to 17 factorial over 14 factorial is equal to 17.16 and times 15 over 4080. So there are the ways that the 3 positions can be filled is P selecting the 3 members is equal to 1 over 4080 is approximately equal to 0.0002. Another is find the probability of being dealt 5 diamonds from a standard deck of 52 playing cards. In a standard deck of playing cards, 13 cards are diamonds. Note that it does not matter what order the cards are selected. The possible number of ways of choosing 5 diamonds out of 13 is 13C5. The number of possible 5-card hand is 52C5. So the probability of being dealt 5 diamond is the probability of 5 diamonds is equal to 13C5 over 52C5 is equal to 1,287 over 2,598,960 is equal to 0.0005. So another is a food manufacturer is analyzing a sample of 400 corn kernels for the presence of a toxin. In this sample, 3 kernels have dangerously high levels of the toxin. 4 kernels are randomly selected from the sample. What is the probability that exactly 1 kernel contains a dangerously high level of the toxin? So the possible number of ways of choosing 1 toxic kernel out of 3 toxic kernel is 3C3 is equal to 3. The possible number of ways of choosing 3 non-toxic kernels from 397 non-toxic kernel is 397 C3 is equal to 10,349,790. Using the multiplication rule, the number of ways of choosing 1 toxic kernel and 3 non-toxic kernel is 3C1 times 397C3 is equal to 3 times 10,349,790 is equal to 31,049,370. So the number of possible ways of choosing 4 kernels from 400 kernel is 400C4 is equal to 1,050,739,900. The probability of selecting exactly 1 toxic kernel is the probability of 1 toxic kernel is equal to 3C1 times 397C3 over 400C4. is equal to 31,049,370 over 1,050,739,900 approximately equal to 0.030.